Good morning, ladies and gentlemen. How's everyone doing? Welcome to day 2 of MTEC ICMASS conference at the Singapore Maritime Week. My name is El Kwan, and on behalf of Informa Markets and Informa Tech, I'd like to welcome all of you, and I'd also like to thank all the speakers who have agreed to share their time and expertise during the last 2 days. We'd also like to thank our sponsors and exhibitors that have made this event possible. So we are live streamed right now. That means we have friends joining us online. And for those who are joining us online through Swapcard, I'd like to invite you to visit our exhibitors, sponsors, and partners tab to network with our exhibitors, engage one-on-one meeting with the speakers, delegates, and wider participants. And please try your luck on our Trivia and Quizzes tab and stand a chance to win 3 $100 Amazon vouchers. For those of us here at the venue, we like to remind everyone to please keep your masks on. Our chairman is held up a bit, but that's not going to stop us from starting our conference proceedings this morning. And so I have the privilege and the honor to introduce to you our first presenter this morning to talk about big data-driven maritime traffic modeling and optimization for reducing maritime traffic emissions. Let's all welcome Xiao, scientist at the Institute of High Performance Computing. Let's give him a warm applause, please.
Okay. Good morning, everyone. I'm Xiuju from HPC A-Star. So you look at this title today, I talk about the maritime traffic emission study. So in today's talk, we'll talk about the research background, the motivation and objective, and then discuss about the work scope and the research framework. Then I will present the result for the CO2 emission estimation in the Singapore port, and then I will summarize my talk and talk about the future exploration. For the motivation, as we know, the decarbonization and green shipping is a timely, important topic in maritime sector. So shipping industry is responsible for around 10% of CO2 as O2 emission. And also for the coastal cities like Singapore, the vessel emission in the port and street area have a potential health and impact on the people living in the coastal cities. So in this research, we try to leverage on the big maritime data technology to model, track, and estimate the emission. And from there, we consider how to reduce emission from the perspective of port operations and traffic management. So for this study, we have 2 critical work components. The first one is about the perception and prediction. So basically generate the insights and the situation awareness of the current emission. Today's talk will mainly focus on this part, and then we can consider how to mitigate and optimize the vessel's behavior and the port operation to reduce the emission. The major data source for this research include the emission sensor data, the vessel onboard emission sensor data, and also ground station emission measurement data. And definitely the traffic and the operation data is one of the critical data source. And another critical data source is the vessels particulars. So we also bring the weather data so we can build a spreading model of the emission in the port area and assess the impact to the urban area. This research actually is international collaboration between Singapore and the German partners. We have a research institute, HPC, where I'm from Singapore part, and DFA from Germany part. We also have the industry collaborators, the company in this domain to contribute from their expertise, such as for the Singapore partners, Forisa is emission control technology company. they help the team to access to the vessels on board sensor data, emission sensor data. And the ship's focus is the maritime tech company, build the infrastructure of the data storage and computation. And for the German side, the Bergmann Marine will help the team to draw into the industry demand. So create the use scenarios for the team. And the Fleetman, Jakarta, is a maritime data vendor. So most of the Greek data for this study is from them. Then the following slide, I will talk about the results of the CO2 emission estimation in Singapore port. So the data for this study is purely based on the AS data. We use half year's traffic data in 2019 for this study. The sample rate is 1 minute, and at each time point, it's about 2,000 vessels, and among them, around 200 vessels are the major type and emission contributors. Then for the vessels, particulars are majorly extracted from the AIS field, but we know the AIS data have the quality issue, there may be stuff from the missing, and also the errors. So we combine multiple sources. One of the key sources is the MPA, Maritime Data Hub. So the method itself is a bottom-up method. So we have a few equations listed here. Definitely at the current stage, we don't have access to the engine data and the fuel type data. So this work actually is built on a few assumptions, such as we assume the engine power is proportional with the dead weight tonnage of vessel, and the emission factor is also referred to one technical report published by US agency. Definitely we'll combine a few other assumptions for this study. Here are some results, statistics about the 6 years emission. First we aggregate the emission and range them in the hourly-based manner. So we can see the daytime has always higher emission than nighttime. And in terms of the vessel movement status, the cruise and reduced speed zone movement takes most of the emission contribution. Later, I will explain the vessel movement status. Then in terms of vessel types, tank, bulk carrier, and also the container ship are top 3 CO2 emission contributors. Actually, you can see those commercial vessels are actually tied with the major business in Singapore ports. If you look at the spatial distribution of the emission pattern and in different time zones, you can see during the midnight, this one, most of the emissions are located in the Singapore street area, because during the night time still have a vessel to move around, travel across the Singapore street. And then during the morning, the more vessels arrive and the Singapore port, then the major ferry and the pilot board station have more emissions, and during the noon time, the traffic get busier and the more emission generated. And during the afternoon time, around 6-7 p.m., then the traffic get quiet, then the less emission generated. So this one is about the vessel movement based emission. So hotel rain is a movement stated that when the vessel slow down the approach to the berth and anchorage area. So most of the hotel rain based emissions inside the port area. And then for the other 3 types, it's majorly based on the categorized based on the speed band, such as cruise is above 12 knots, and reduced speed zone is 9 to 12 knots, and marine is for around 5 to 8 knots. Actually, you can see most of the emissions actually is in the street area. In terms of the vessel type based emission, tanker takes the most of the is the most emission contributor, followed by the bulk carrier, container ship, and the vehicle carrier. We normalize the color scale so you can compare this set of diagram to see the difference. We also build a visualization tool for this study. Definitely, this is quite an initial version of the visualization to basically support the team to develop the model and do the assessment. So we can have some plan for to visualize the result to find the identified problem. Actually, this is a grid-based visualization tool, so you can click the grid to see the emission along the time, and also can select the different type of the vessels to see the emission for that type. The research is still ongoing. Definitely we will enhance this. So as a summary, in this study we explore the framework for the emission research, and we build the bottom-up method to estimate the CO2 emission in Singapore waters, and got a few observations. And for the future work, definitely we want to release the assumptions to by including more data, relevant data for the critical ones, such as the engine data and the fuel type data. And then we will build the deep learning model to link the vessels navigation state with the emission. Definitely the methods will be adapted and adjusted to for the LOX emission research. So that's all for my talk. Thanks.
Thank you. Thank you.
Thanks.
Hi, good morning. I'm Jasmine Lam from Nanyang Technological University, NTU, Maritime Energy and Sustainable Development Center of Excellence. All right, so after a very interesting presentation, now we will have question and answer. Any questions for
So I didn't get
the speaker?
So there's a question session, right? Is there a question session?
Yes, after,
Okay.
after presentation,
Okay.
there will be about 5 minutes of question and answer. All right, yes.
Okay, good morning. Okay, I'm Zhang from Maritime Energy and Sustainable Development Center of Excellence. Okay, thank you for your presentation. I have one question is about the difference between the cruising mode and reduced speed mode. So I noticed from your figure, right, it seems that there isn't much difference there. I want to understand what is the key difference from these two operating modes. Because from what I understand in Singapore, usually by regulation, the vessel should travel at a limit of, let's say, 12 knots. That is the speed limit. So
Yeah.
I want to understand what's the difference between cruise and the transit, the reduced transit mode.
Okay, so your question is about the movement-based, the movement state-based emission, right? So yes, actually for Singapore case, I think the cruise and speed reduced zone, the pattern actually is quite similar. So for these two type of the movement-based emission, we can combine together. Definitely for the hotel steering, the state is when the vessel approach to the berth or anchorage. So this one can be combined with the operation data to identify. Because for the hoteling status, the engine, in this study we assume only the auxiliary engine is on, and the proportional engine is on or off. So actually this is referred to one of the technical publication by the US agency. So this is why we should build, because the engine working state is different, so we should consider about the emission for different navigation states. Yeah, thanks.
Thanks. All right. Another question?
Hi, I'm Mr. Quek from Ocean Master, a member of Singapore Shipping Association Offshore and Renewable Energy Committee. Very insightful, well, very exciting. In fact, my first question, are this report going to be shared openly? Second question, I noticed that one of the chart you show, the vessel goes south-easterly, the emission is almost, do not see a red line, very fine. By the moment you turn left after the rifle slide how, you go northeasterly direction and the red line is very thick. Any particular reason?
Okay.
I'm not sure, are you able to recollect that, your slide? Generally, it goes southeasterly direction. The vessel emission is very low. By the moment you turn left after the rifle slide how, and I notice the emission is getting stronger. And very unique. I see all the slides you have. By the way, I'm the seafarer before. I'm familiar with all the vessel movement here, but I didn't really see the emission. This is the first time I see this data. That's why I'm very excited and well, wish to know actually any observation you make or any further inquiry you check on this particular data.
Okay. So first of about your first question, yes, the team will consider publish the results when we do more rounds of validation. About the second question, actually, I didn't get that quite clear. You mean which portion of the Singapore street have more emissions?
Are you familiar with the street name? Singapore Street, there are basically two traffic directions. One is the westbound, one is the eastbound. First, I'm referring to eastbound.
Yeah.
Eastbound, there are two general course. One, you're going from Malacca Street, you reach the Tanjong Pier, you go southeasterly.
Yes.
When you reach the point south of Rifles Lighthouse, you turn left or turn port, then you go generally direction of easterly. Okay, my question is the one in the first course before the Rifles Lighthouse, with the southeasterly direction, the emission is very low. The moment you turn left, you go toward the easterly direction, you can see the emission is stronger.
Okay, I think this is based on the port operation and also the port business. So depends on the type of vessels. You see, for the pattern of the spatial distribution of the emission pattern, you can see most of the street, whatever the westbound or eastbound streets, the traffic flow, the traffic lane, they have a lot of the emissions. And I think just now you see about the one you turn left from the, you mean the Tuas, around the Tuas Island, that one they have a lot of tank terminals. So for the tank ships, I think that part.
Sorry, my interruption. I think you're referring the area is not the one referring. I think we can talk about this after your presentation.
Yeah, thanks.
Thank you very much. Yeah.
Yes, thanks a lot. Thanks, Dr. Xiao, for the presentation and answering the questions as well. All right, so because of time, actually, there is a question from Pigeonhole as well, but I think we'll leave it to the question to later on, for example, during the networking session, during the tea break.